Hello, my name is Ajay Shete. I am a graduate student at NY Tandon School of Engineering, pursuing my master's degree in computer science. I have started working on a facial recognition project based on neural networks. After conducting my research, I have realized that the machines were having a hard time identifying the people with different skin complexion. And based on my research, I found that a limited number of parameters for plotting the points on the face were responsible for this. So, in the dataset I have acquired, there are numerous points plotted on the face, 15 to be precise, which will try to precisely identify the person's feature irrespective of the skin color, thus enabling a much better facial recognition system. So, let's dive into our program. Hello. So, I'll be talking about the facial key point detection. Now, the dataset consists of 7,049 files, which are 96 by 96 grayscale images converted to CSV. For the dataset, I have plotted x and y coordinates of 15 key points. So in total, we have 30 parameters. The very first problem that arises is that not all the key points are labeled. So cleaning of the data is essential. Now first, we'll be training our data using the trained dataset. We'll first check the total number of labels available for every column. And as you can see, some of the columns have more values as compared to the others. Now in this case, the right eye center have many of the data set have labels of eye centers, but not of the inner corners or the outer corners. So we'll be cleaning this data. Now, as you can see the Y, so only 2140 images of all the data set have all the 30 parameters. So for now, we'll be considering only these for all files, but we'll get to the others later on. Now coming to the neural network part of this, uh, I have used the lasagna Nestor momentum as I found out that this worked very well with the data that was given. I have defined the layers as it provides a better compatibility with scikit-learn's pipeline and parameter search feature. Setting the dimension shape to none allows us to have variable batch sizes. Having the output linearity to none, we obtain the output units as a linear combination of activations and hidden layers. The update will keep on updating the weights of our network after each batch. And we are using the lasagna's Nestor momentum gradient descent. Update learning rate defines how large we want the steps of the gradient descent updates to be. The last set of parameters include um, the last set of parameters declare that we are dealing with a regression problem. 400 epochs we are willing to train by setting the verbose to 1. Finally, these lines indicate loading the training data to the neural net, and we find this value. This gives us the training loss and the valid loss. After this, we'll try to visualize this data more better. So I have used NumPy for the square error and matplot to plot the graph. So here we'll be taking the train loss that we have obtained above into a train loss variable and valid loss to the variable valid loss variable, and we'll try to plot it in a graph. Now looking at the graph, um, you'll see that the model seems a bit overfitted. Here I'll also display a few of the pics from the test. As you can see, these are a few of the pics from the test. And in this test, the program is trying to plot all the 15 points on the faces, on the two-dimensional faces that are there. But as you can see, some of them are not having all 15 of them. So this is the result of our program as of now. As of now, I was taking into account all the parameters, but now I'll be using convolution neural networks. CNN reduces the number of parameters that need to be learned while retaining high expressiveness. That is, the neurons are connected only to a subset of neurons from the previous layers, and weights are shared between subset of neurons. But the thing is, CNN requires me to configure the Theano to use my GPU instead of the CPU. I wasn't able to successfully do this, but the thing is, the previous steps also needed GPU, but I was able to run them with slightly more time on my CPU. All these steps. The CNN process requires a minimum of 20 minutes to run using the GPU, and when I ran it using CPU, it only gave me 50 results over a period of 1 hour. Uh, so, in the end, I would like to say that I wish I had utilized my time better, but this is the basic idea of how I would like to use my time in the data incubators. I would like to research more on this. I was able to create this program by referring to a Daniel Norris program. Apart from this project, I've also worked on the, the customer churning process. As you can see here, this is also an co-equal competition in which I have ranked 7th. So the customer churning process and also the spell checker program, which used to solve errors of one or two or three uh, places, three pack of three words, three letters. Sorry. So I have used linear classification, logistic regression, k nearest neighbor, and also neural networks and some of these. This was an interesting test, and I sincerely apologize for not being able to give enough time for this test because of my 3 assignments and 2 submissions which are due next week. Additionally, I would like to say that I've been studying data science for 3 months now, and I'm really enjoying the process of learning, experimenting, and analyzing data. I will always I will always keep trying to find better and innovative ways to analyze and process data. Hope to hear back from you soon. Thank you.